Welcome back to another episode of the CSK8 podcast. My name is Jared O'Leary. If you're new to listening to this podcast, each week alternates between an interview with a guest and a solo episode where I unpack some scholarship. In this particular episode, I am unpacking the paper titled Connecting K16 Curriculum and Policy, Making Computer Science Engaging, Accessible, and Hospitable for Underrepresented Students. And this paper is by Joanna Goode. As always in the show notes, there are links to this paper in the description. All you have to do is simply click on the title, and if you click on the author's last name, then it'll take you to their Google Scholar profiles where you can read more publications by this particular author. All right, so here's the abstract for this paper. It's very short. Quote, in this paper, a K16 computer science reform effort is described as an effort that depends on curriculum development, professional development, and collaborative policy strategies. End quote. If I were to summarize this paper into a single sentence, I would say this paper unpacks the development process behind the Exploring Computer Science Curriculum, ECS, as well as the policy work that occurred in parallel with the curriculum development. So this week's episode is going to focus in particular on some of the broader policy and curriculum related things that we can do to broaden and diversify computer science education. But the episode 2 weeks from now is going to talk about what individual educators can do to broaden and diversify their own programs in the classroom. So this week's is going to be about larger implications, and 2 weeks from now is going to be about implications for individuals. All right, so this paper begins by talking about CC, which is an acronym for Computer Science Equity Alliance. So the letter C, S-E-A. And this began in 2004 in the LA Unified School District, Los Angeles Unified School District. All right, so here's a quote from page 22 that kind of talks about what CC is. So, quote, charged with the results of a 3-year qualitative research study which highlighted instructional and structural barriers to computer science education for girls and students of color, this alliance includes educational researchers, university computer scientists, K-12 school district officials, and leadership from the Computer Science Teachers Association, CSTA, end quote. All right, so CC was all about trying to increase enrollment and diversify students who were taking the APCS course. Now, here are some findings from the approach that CC took. This approach of providing instructional and pedagogical resources and structural support to teachers led to staggering results. The number of students studying APCS in LA Unified School District tripled, girls quadrupled, Latinos quintupled, African Americans doubled. However, formative and summative research identified a significant tension between the Alliance's goals of accessibility and the goals of the APCS course. Teacher interviews revealed that as a first course in computer science, the learning curve was too steep for the students to learn APCS content in time for the May exam. Teachers also reported that the course's focus on program methodologies in Java failed to attract the interest in students who were not already enamored with computing, end quote. Okay, so obviously it's great that the percentages and numbers of students who took APCS in LA Unified School District grew. That's great. Things are more diverse as a result of CC. However, it was very clear that there were some problems in terms of who could take the APCS course. And because there were no alternatives in terms of computer science that didn't have an AP label to it or exist under the AP umbrella, they wanted to create some kind of other curriculum that could be used. So exploring computer science came out of this need. So although CC doesn't exist anymore, a recent discussion among CSTA chapter leaders at a conference a couple weeks ago at the time of this recording, many of the leaders actually called for this alliance to come back in some form or another to kind of help with some of the equity issues that are still pervasive within computer science as a profession and within the field of computer science education in terms of who is participating and in what ways. Now, one way that you could actually participate in equity through CSTA, the Computer Science Teachers Association, is to become an equity fellow. Now, by the time this episode actually comes out, you won't be able to apply for this year's equity fellowship. However, I will include a link in the show notes so you can learn more about it so that way you can apply to it for next year, which I believe it came this year with a $2,000 stipend, and it allows you to connect more with other educators who are also seeking to improve equity in computer science. Okay, so to recap, so far, we have CC, which was trying to increase enrollment in APCS courses and whatnot and offerings. And students were applying and it was more diverse than it was in the past. However, they identified some issues. So as a result, one of the recommendations was to create a computer science curriculum that was more accessible and did not require the same prerequisites that an AP course did. So this is where Exploring Computer Science curriculum comes into play. Okay, so what is Exploring Computer Science, the curriculum? So here's a quote from page 23. It sought to develop, quote, knowledge and content, learning theory, and the communities from which students draw their informal knowledge about the world, end quote. So the framework was developed in collaborations with researchers and practitioners, which honestly, I wish there was more of that. A lot of curriculum is developed by people who either have not been in a classroom. So for example, like software development companies who are just trying to create this new fancy software, or by researchers who are CS education researchers who have worked at the undergraduate level but have not actually taught in a K-12 setting. So to kind of work through some of those shortcomings and lack of experience, you can collaborate with people. So if you're an educator who's interested in these kind of curricular initiatives, what I'd recommend doing is like reaching out to some of the professors in the colleges near where you live or where you previously attended and see if there are ways that you can collaborate with them to create content like this. So this curriculum aligns with many of the things that have been discussed by guests and myself in other episodes in the interviews. So here's a quote from page 23 that just kind of summarizes the overall approach. Quote, the course adopts an inquiry-based learning environment which requires students to engage in complex computing projects. Ongoing opportunities for collaboration, communication, and multiple ways of knowing are embedded into the design of the course, end quote. In general, I really like inquiry-based approaches to learning, where you're using questions to kind of guide further understanding, especially when it's embedded within an individual's interest or within some kind of a community problem or need. Okay, so the team that developed this was a team of K-12 and university CS experts who created some different course topics, which resulted in 6 instructional units. And they are 1, human-computer interaction, 2, problem solving, 3, web design, 4, introduction to programming, 5, robotics, and 6, computing applications. Now, it was kind of funny reading through this because the web design in particular, at one point they mentioned like basically designing a MySpace page, which just thinking back to MySpace, that just seems like a century ago as opposed to a decade ago. A lot has certainly changed since ECS first came out. Now, on the curriculum writing team, they did have 5 teachers actually assist with writing this, which again, I really appreciate. And when they piloted this, they piloted it at 7 different high schools where they had just under 300 students, and it was comprised of 42% who were female and 92% who were Black or Latino. Okay, so they created this curriculum, and then they implemented it in the high school setting. What were the results of this particular pilot study? So here's a quote from page 23. Quote, using pre- and post-survey instruments, research showed that participation in the course resulted in change students' perceptions of the usefulness of computer science in a positive direction, change students' beliefs about the appeal of computer science in a positive direction, increase students' perceptions of computer science as enjoyable and stimulating, increase students' motivation to stick with a difficult problem, students' willingness to have the answer given to them instead of working it out decreased, end quote. Now, if I get nerdy real quick, so the p-values on this indicate that at the worst case scenario, there's a 95% probability that this correlation existed, and on the best case scenario, on one of those indicators in particular, it was 99.9% correlated, which all of these are statistically significant and likely suggests that ECS help improve each one of these things that I just read off, which is great. Now that we know what ECS is a little bit about, and we know what some of the topics are within it, and we know what some of the results are from using this particular curriculum, let's talk about some of the other things that went on in parallel with the curriculum implementation itself. So one of them is PD. So PD focused in particular on modeling engaging pedagogy. So for example, computer science that was, quote, taught through role-playing, jigsawing activities, pair and small group collaboration, structured tinkering, multiple solutions, utilizing manipulatives, simulations, English language learner modifications, journal reflections, and interdisciplinary connections. Rather than providing the answers, the instructors facilitated participant discussions of problems and drew from the rich and varied expertise in the classroom, end quote. That's from page 24. I really like their approach to PD by having a variety of things going on in it. This is what we also model at Boot Up PD, which is where I work. It's a nonprofit. And we too are all about facilitating in terms of if a teacher has a question, we usually respond with several more questions to kind of help guide them towards their understanding, or pairing them with other experts in the room who may have solved similar problems, or at least be able to assist with solving it. And this gets us so that teachers are starting to think through, okay, what do I need to know to be able to facilitate this in a classroom setting, rather than relying on somebody else that's an outsider to provide expertise. So another thing that they really focused on in PD, which is something that I also recommend, is developing a community of practice that included both novice and veteran K-12 educators. And one of the things that they also included actually was CS educators from the university level, so people who taught like undergraduate or graduate computer science courses. Now, if you are interested in actually kind of developing a community of practice, I do recommend either checking out CSTA, Computer Science Teachers Association, or check out CS for All Teachers, which is different than CS for All. So I'll include a link to both CSTA and CS for All Teachers in the show notes. Which, by the way, CS for All Teachers is basically a discussion forum where you can go into different subforums based on different categories, such as like elementary computer science or high school computer science, or even a specific curriculum, and then you can kind of share and discuss in there. Another important aspect about this curriculum is they had ongoing follow-up sessions. So rather than just saying, okay, we're going to spend a week learning this thing, and then you're certified as knowing everything you need to know for life, instead, they would follow up with more professional development offerings throughout the school year. This is the approach that we also use at Boot Up PD, in that a typical district that works with us will see them over the course of 2 years, about 4 PDs each year, so like 1 per quarter. And the reason why we particularly like it is because we're able to introduce an idea. Teachers are then able to go and apply it into their classroom over the course of a month or 2. And then when we come back, we kind of unpack and dive deeper based off of their experiences that they had in the classroom. So we're constantly introducing new ideas while also giving time to implement the ideas into the classroom in case people have questions. Okay, now at the policy level, the author indicates that policy was multi-tiered. So the state released a call for new college preparation courses. So the team collaborated to get the release of Exploring Computer Science as a CTE course. Now at the district level, they had to get district approval to include this new course into their classes. Now here's a quote from page 25 that gets at the importance of having district administrators on a team to assist with this. Quote, "Without this insider status, maneuvering within this complex system would be difficult given the tight resources and multiple demands of school districts." End quote. So if you are a researcher who's trying to get something implemented, highly recommend having district administrators who can help guide you through this process and basically be an insider for you. If you are a teacher who is trying to get some implementation, it helps to have friends in higher up positions that can also help with this as well. And on that note, teachers themselves also helped with the implementation at the school level because they were able to make connections and get other teachers to sign up to participate in this particular curriculum offering. So here are the final takeaways from the paper itself. So 1, this entire process was very collaborative. So there were researchers involved, there were curriculum developers involved, there were administrators and policymakers, there were teachers, etc. This was a large undertaking. And 2 weeks from now, I'm going to unpack another paper by Joanna Goode that is specifically going to talk about what individual teachers can do to help diversify their programs, rather than focusing on this big picture stuff that I'm talking about in this particular episode. Another key takeaway is that the curriculum resources that they developed are adaptable elsewhere. So at the time of the writing, there were limited opportunities for computer science curriculum. However, we now have the opposite problem that we have a ton of options out there. One of the things that I really like about a key takeaway that was highlighted is that the resources could be adapted to fit different populations, different demographics, different locations, etc. This is very important when trying to create some kind of a curriculum that can be implemented anywhere. So as an example, all the curriculum resources that I create for Boot Up have Google Docs and slide decks and other things that teachers can make copies of, and then they can modify to include their own content in addition to the stuff that I have created for them. Another key takeaway was that researchers and curriculum developers need to work with teachers. So here's a quote from page 26. Quote, Working with teachers is critical because the implementation of reforming computer science education ultimately takes place in the classroom setting, end quote. Now, I've ranted about this enough on other episodes. The short summary is basically that there are a lot of well-intentioned software development companies who are creating the next greatest thing that they think computer science educators need, but they actually don't have any experience teaching in the classroom, so the resources that they create are not super helpful for students or for teachers, but they do look nice. And the final key takeaway from this is that success was measured based on broadening participation, not on signing up to be a CS major. So this is really important and is something that is reiterated by other guests that have been on the show and some of the stuff that I have mentioned in other episodes as well. Not everybody who goes into computer science education in the K-12 setting needs to come out, or even should come out, with the desire to join computer science professionally. You could just do it for fun. Like some of the earlier Unpacking Scholarship episodes, I talk about mod culture and the implications in the K-12 setting. Mod culture is something that you can do for fun. You don't have to get a job doing it, although many people do. For example, I've mentioned in other episodes that I proposed to my wife by modifying the video game Minecraft. That's just one example of a way that you could use computer science without having to do it for a vocation. Okay, so in each Unpacking Scholarship episode, I like to kind of share some of my lingering questions or thoughts. So one of my questions is, if you can't afford professional development for educators in your district, how could you use model professional developments like ECS or what I've talked about at Boot Up in other episodes, in this episode, to provide PD to your own district? The reason why I bring this up is because I did this in the former district that I was in. So it was a K-8 district, and I provided the PD for it because the district couldn't bring in outside professional development. What I recommend if you are in a similar position and have this question is to listen to the episode with Clark Merkley, which provides some suggestions on things you can do to get grant support and funds for professional development. But two, also consider what your expertises are and the people that you know, and in the communities that you will hopefully join, like CS for All Teachers and CSTA, and then see what kind of professional development you can piecemeal for your district. Now, I will give the caveat that this is a much harder approach. It's going to require a lot more time on your end, but it is cheaper than hiring outside organizations. Okay, so another question that I have is, how might individual teachers start grassroots CS implementation rather than relying on top-down implementation like was discussed in this particular paper? So the episode 2 weeks from now will actually kind of provide some suggestions for what you can do as an individual educator in your classroom to diversify your class and your program. So just giving you a little tease for the episode for 2 weeks from now. So now that I've kind of unpacked the multifaceted nature of what goes into computer science implementation, what I would encourage you to do is think about what expertise and roles you might be able to contribute to projects like this, and how you might be able to create a team with other people who have different connections and expertise and understandings that could assist with creating a project like this for your district, your community, or your state. Now, the reason why I'm bringing this up is because a lot of grant funding is being diverted and rerouted towards other initiatives that have come up as a result of COVID and people having to work from home. So, for example, better internet, access to devices, things like that. So money that may have gone towards professional development is now being funneled into other areas. And so we need to kind of start a grassroots movement in some communities by working together with researchers and organizations and curriculum developers to continue computer science education and to ensure that it doesn't take a back burner so we can focus on reading, writing, arithmetic. And I could honestly rant for a very long time about why only focusing on those 3 areas is problematic, but maybe I'll save that for another Unpacking Scholarship episode. Anyways, so 2 weeks from now is going to be another Unpacking Scholarship episode where I'll kind of talk about what you can do as an individual educator in your program. But next week is going to be another interview. And if you'd be so kind, please consider sharing the podcast with anyone else who might be interested in computer science education. For example, if you do want to develop a team of people who can work together to kind of solve this problem of lack of support for computer science in your community, perhaps you can share this episode with them. Thank you so much for listening. I hope you're all staying safe and are having a wonderful week. I will talk to you next week.